creating equivalent fractions, adding and subtracting fractions with unlike denominators. So this is a helpful strategy for solving addition and subtraction problems with fractions with unlike denominators. So to add and subtract fractions, the fractions must have the same denominator. This requires creating equivalent fractions or fractions of equal worth for each of the fractions in the equation. The following is a strategy that can be used to easily create equivalent fractions in order to solve the equation. So our first step that we're going to look at is we're just going to simply look at the equation, and we're going to kind of rewrite or kind of create almost a template to get ready for our equivalent fractions. So we're going to set up our equation. So let's say that we're solving, we're going to do an addition problem. So my equation is 1/4 plus 2/3. Now, as you can see in this equation, our denominators, that bottom number in our fractions, the 4 and the 3, are not the same. They do not have the same denominator. And we can't add or subtract these fractions if they don't have the same denominator. They kind of have to be on the same playing field before you can solve them. So what we're going to do first is I'm just going to simply kind of set up a new equation. And it's just kind of a blank equation right now because I don't have my equivalent fractions yet. But what will happen is once we find those, whatever is equivalent to 1/4 is going to go here. Whatever fraction we find that is equivalent to 2/3 but has the same denominator as the 1/4 equivalent fraction will go here. So these will be where our equivalent fractions will go. So let's move on to step 2. In step 2, here's your paper so far. 1/4 plus 2/3. And then remember, in step 1, we were kind of setting up our template for our equivalent fractions. Now, in step 2, we're actually going to go through the process of finding equivalent fractions. What I want to do is let's come down on our paper, and I'm going to write 1/4, and then I'm going to draw a little line just to kind of separate our 1/4, and then I'm going to write just below that green line the 2/3. Now what's going to happen is when we're creating equivalent fractions, remember when you're creating an equivalent fraction, what you have to do, and I'm going to use 1/4 as an example, I have to multiply both the numerator and the denominator by the same number. So if I say, let's multiply by 2, I have to multiply both the numerator and the denominator by the same number. In this case, I'm multiplying by 2. And when I do that, 1 times 2 is 2. 4 times 2 is 8. So my equivalent fraction for 1/4 when I multiply by 2 is 2/8. Those are equivalent, or fractions that have equal worth. So now what I'm going to do to kind of make it a little bit easier for myself, do that again. I'm going to come down, and I know that if I multiply 1/4 or 2/3 by 1, I'm going to get the same thing. I'm going to still get 1/4 and 2/3. So I'm going to come over and I'm going to say, okay, well, what about times 2? So what I'm going to do here, just like I showed you above a moment ago, I'm going to multiply both the numerator 1 and the denominator 4 by 2. So when I do that, 1 times 2 is 2. 2 times 4 is 8. So there's my first equivalent fraction for 1/4. Now I'm going to drop down to the 2/3 and I'm going to do the exact same thing. So what I'm going to do, I'm going to take and multiply 2 times the numerator 2 and 2 times the denominator, 3. So here, when I do this, 2 times 2 is 4. 2 times 3 is 6. Now, looking at the denominators, I see right now I have an 8, I have a 6, I have a 4, I have a 3. I don't have any denominators that match, that are the exact same number. So I'm going to keep going. So I'm going to come up here and I'm going to say times 3. Now don't make the mistake of just going to the previous fraction and multiplying. That's a no. What you want to do is still go back to that very first fraction. That's the one you're trying to find an equivalent fraction for. So always go back to your very first fraction in the list. So now I'm going to say 3 times 1 is 3. 3 times 4 is 12. So now I have 3/12. Again, I'm going to drop down to my 2/3. Again, you're going all the way back to this very first fraction in your list. So 3 times 2 is 6. 3 times 3 is 9. Now again, I'm going to go back and I'm going to look at all of my denominators. I'm going to see, do I have any from the top that match any from the bottom? And I do not. I don't have any that match yet. So I'm going to go back and let's keep going. So next I'm going to multiply by 4. Again, go all the way back to your first fraction, 1/4. So 4 times the numerator 1 is 4. 4 times the denominator 4 is 16. Then I'm going to drop down to 2/3. 4 times 2 is 8. 4 times 3 is 12. Now you're going to stop and you're going to look at all of your denominators. So we have 4, 8, 12, 16, 3, 6, 9, 12. Well, now I can see that I do have denominators that match. They're the same. And I'm going to circle those to really bring my attention to them. So I see that for 1/4, I have 3/12. For 2/3, I have 8/12. So here's where my denominators, those bottom numbers in the fraction, match. They are the same. So now I've found an equivalent fraction for 1/4 and an equivalent fraction for 2/3 that have the same denominator. So I'm going to take all this over to our last step, step 3. So I'm going to take all of this. We're going to copy and take this over to step 3. All right. So here, at step 3, we're actually going to be able to solve the equation. And here's how. So we're going to take, I'm going to label this over here. This was our step 2, so we don't forget this. Now remember, over here, we had step 1, where we kind of set up the framework to be able to plug in our equivalent fractions to solve the equation. And I still have my original equation here as well. I want to really remember what I'm doing here. Now, I'm going to write my framework just a little bigger this time so I can show you what's going on. So I'm going to set this up. Now, what's going to happen is I'm going to take and look at my first fraction, the 1/4. And I'm going to say, well, what was the equivalent fraction for 1/4 that had 12 as my denominator? Well, I see that it is that 3/12. So what I want to do, and you're going to have to actually write this. I'm going to just kind of drag and drop. But I'm going to take my 3/12, and it's actually going to travel and be the first fraction in my new equation, my rewritten equation that's going to have the common denominators in it. Now the next one I'm going to look at is the 2/3. Well, for 2/3, I'm going to come down here to my 2/3 line and look and see, well, what was the equivalent fraction for 2/3 that has 8/12 in it? Or that has 12ths as the denominator. And so I see it's 8/12. So I'm going to take 8/12, and it's going to go and live in the side of my equation that was originally 2/3. So now you can see, I'm going to kind of clean this up a little bit so you can kind of see that now I have my equivalent fraction for 1/4, which was 3/12. And see how they are aligned. The 3/12 is directly below the 1/4 to show that that is the equivalent fraction for 1/4. My 2/3, the equivalent fraction is 8/12. And of course this is not aligned perfectly, but if you were to line it up, that 8/12 is the equivalent fraction for 2/3. So now I have 12ths as my denominator in this fraction, and I have 12ths as my denominator in this fraction. So now I know that I can add these two fractions together. And remember, when we're adding and subtracting fractions, we only add or subtract the numerators. We do not add or subtract the denominators. They just carry over. So I say 3 plus 8 is 11. And then I simply bring my denominator over 12. So my final answer, because I cannot simplify this fraction, my final answer is 11/12.